Let us solve one more example, assignment problem with restrictions. So this cost matrix is given. Look at the first row. Operation A, we cannot assign to machine number 3 because this cost C13 is not given. So operation A cannot be performed on machine 3. Similarly, there is a restriction that operation C cannot be performed on machine number 4. So these are the two restrictions in this assignment problem. How to handle these restrictions? We take a very large cost of assignment for these two operations. That is, we take C13, this cost as infinity, as well as we take C34, this cost, C34, third row, fourth column cost as infinity, so that when we perform addition, subtractions, these costs will not change to 0 and we cannot make an assignment in these cells. So this is how restrictions are handled, and other numbers in the matrix we keep as it is, 5 5 infinity to 6, then 7 4 2 3 4, 9 3 5 infinity 3, then 7 2 6 7 2, and last row is 6 5 7 9 1. So now let us apply step number 1. Subtract smallest number of each row from all the numbers in that row. So what is the smallest number in the first row? Smallest number is 2. Subtract 2 from all the elements in first row. We get 5 minus 2, 5 minus 2, infinity minus 2 is infinity. 2 minus 2 is 0, 6 minus 2 is 4. Smallest element of the second row is 2. Subtracting 2 from all the elements of second row, we get 7 minus 2, 4 minus 2, 2 minus 2, 3 minus 2, 4 minus 2. Smallest element of the third row is 3. Subtracting 3 from all the entries of the third row, we get 9 minus 3, 3 minus 3, 5 minus 3. Infinity minus 3 is infinity, and 3 minus 3 is 0. Smallest element of the fourth row is 2. Subtracting 2 from all the entries in the fourth row, we get 7 minus 2, 2 minus 2, 6 minus 2, 7 minus 2, 2 minus 2. Then smallest element of the fifth row is 1. Subtracting 1 from all the entries, we get 6 minus 1, 5 minus 1, 7 minus 1, 9 minus 1, 1 minus 1. Now apply step number 2. Repeat step 1 for column. Now in the first column, smallest entry is 3. Subtracting 3 from all the numbers in the first column, we get 3 minus 3, 5 minus 3, 6 minus 3, 5 minus 3, 5 minus 3. Now in the second column, smallest number is 0. Subtracting 0 will not change elements of second column. So we get 3, 2, 0, 0, 4. In the third column, smallest element is 0, subtracting 0 will not change elements of third column. So we get infinity, 0, 2, 4, 6. In the third, fourth and fifth column, again there is no change because subtracting 0 will not change the numbers in the fourth and fifth column. Now apply step number 3, cover all zeros with minimum number of horizontal and vertical lines. So let us perform step number 3 here. Starting from the first row, look at the rows containing single zero. So first row contains 2 zeros, second row contains single zero. So we made an assignment here in the second row, and when we make assignment in a row, we have to draw a vertical line. Now in the third row, there are 2 0. In the fourth row, there are 2 0. In the fifth row, there is a single zero. So make an assignment and draw a vertical line. Now look at the columns with single zero. First column contains single zero. Make an assignment there. And when we make an assignment in a column, we draw a horizontal line. Now second column contains 2 0. Fourth column, there is no zero. Now again look at the rows containing single zero. First and second row, there is already an assignment is made in the first and second row. Now third row, look at the third row. Third row contains single zero. So make an assignment in the third row and draw a vertical line because we are making an assignment in a row. So all zeros are covered, and how many lines we have drawn? 3 vertical lines, 1 horizontal line. Total 4 lines we have drawn, and 4 is not equal to order of the matrix. So this is not an optimum assignment. This is not a solution. We have to apply step number 4. So we require smallest uncovered number. The smallest uncovered number is 1 here. What are the uncovered numbers? This 2, 3, 2, 2 and 1, infinity, 5, infinity. These are the uncovered numbers, and smallest uncovered number is 1. Smallest uncovered number is 1. So what is a step number 4 now? Subtract this 1 from all the uncovered numbers. Add it to the numbers which are on the intersection of horizontal and vertical lines. There are 3 numbers on the intersection, 3, infinity and 4. We have to add 1 to these 3 numbers and do not change other numbers. So let us write down the numbers in the first column. 0 will not change because it is on the line. From the uncovered number, we have to subtract 1. So 2 minus 1 is 1, 3 minus 1 is 2. So we get 0, 1, 2. Let us write down these 3 numbers in the first column. Then we are subtracting 1 from the uncovered number. So we get 1 here, 2 here. Then 1, 1. Last 2 numbers are 1, 1 in the first column. Let us write down elements of the second column. 3 is on the intersection, so we have to add 1 to this number. 3 plus 1 is 4. Then other numbers we have to keep as it is. These are the numbers on the line. So 4, 2, 0 in the second column. 4, 2, 0. 420, then 04 as it is. Elements of the third column. Infinity we have to is on the intersections. We have to add 1. But when we add 1 to the infinity, infinity plus 1 will be infinity. So infinity 0, 2. Other numbers as it is. 4, 6. Now elements of the fourth column. All these numbers are uncovered number. We have to subtract 1 from these numbers. So 0 as it is, 0. And 1, subtract 1, we get 1 minus 1 equal to 0. So 0, 0. And from the infinity, when we subtract 1, it remains infinity. Infinity minus 1 is infinity. So 0, 1 minus 1 is 0. And infinity minus 1 is infinity. So first two numbers are 0, 0. Then infinity minus 1 is infinity. Then 5 minus 1 is 4, 8 minus 1 is 7, 4 and 7. Elements of the last column. On the intersection we add 1, we get 4 plus 1, 5, other numbers as it is, 5, 2, 0, 0, 0. So this is a step number 4. Now we have to repeat step number 3. Repeat step number 3. That is cover all zeros with minimum number of horizontal and vertical lines. Starting from the first row, look at the rows containing single 0. First row contains 2 zeros, second row contains 2 zeros, third row contains 2 zeros, fourth row contains 2 zeros, fifth row contains single 0. So make an assignment in the fifth row and draw a vertical line. Now look at the columns containing single 0. First column contains single 0, so we draw horizontal line. Then second column contains 2 0, third column contains single 0. So make an assignment in the third column and we draw a horizontal line. Fourth column, there is no 0. Now still there are some 0 left. Again look at the rows containing single 0. First and second row already assignment is made. So in the third row there is a single 0 now in the third row. So make an assignment there, and when we make assignment in a row we have to draw a vertical line. So in this way all zeros are covered. Now the number of horizontal and vertical lines are 4. It is not equal to 5. So this is not an optimum assignment. We require 5 assignment. And here we have 4 assignment. 4 lines and 4 assignment. So again apply step number 4. When we do not get solution in step number 3, we repeat step 3 and 4. So apply step 4 now. What is the smallest uncovered number? 211, 246, infinity 47. So 1 is the smallest uncovered number, right? So subtract 1 from all the uncovered number, add it to the numbers which are on the intersection and do not change other numbers. So let us write down elements of the first column. 0 as it is because it is on the line. 1 as it is because it is on the line. So 0 and 1. Smallest uncovered number is 1. So apply step 3 again. So 0 and 1 as it is. From the uncovered number we subtract 1. So we get 2 minus 1 2 minus 1, 1 minus 1, 1 minus 1. Let us write down elements of the second column. 4 is on the intersection. So on the intersection we add. 2 is also on the intersection. So we have to add 1. So 4 plus 1, 5. And 2 plus 1, 3. 0, 0, 4 as it is, because these are the numbers on the line. Then elements of the third column, infinity and 0 as it is. Now subtract 1 from the uncovered numbers. 2 minus 1, 4 minus 1, 6 minus 1. Now entries of the fourth column, 0, 0 as it is. From the infinity subtract 1, we get infinity. Then 4 minus 1 is 3, 7 minus 1 is 6. Then elements of the fifth column. On the intersection we add. 5 and 2 are on the intersection. So 5 plus 1 and 2 plus 1. Then other number 0, 0, 0 as it is. So this is a cost matrix obtained in step number 4. Then repeat step 3 again. Look at the rows containing single zero. First row contain 2 0, second row contain 2 0, third row contains 2 0, fourth row also contains 3 0, fifth row contains 2 0. Now first column contains 3 0, second column contains 2 0, third column contains single 0. So let us make an assignment in the third column and we draw a horizontal line for this assignment. Then look at the column number 4. There is a single 0 here because this is already crossed. So there is a single 0 in the fourth column. So we will draw a horizontal line again. Fifth column contains 3 0. Now again look at the remaining rows. Row number 3 contains 2 0, row number 4 contains 3 0, row number 5 contains 2 0, column number 1 contains 2 0, column number 2 contains 2 0, column number 3 and 4 already assignment is made. Now in column number 5, 3 zeros are there. So we observe that every row where we have not made an assignment contains more than 1 0. Every column where we have not made an assignment contains more than 1 0. So this is a situation where we get alternate solution. So row number 3, 4, 5 contains more than 1 0. Column number 1, 2 and 5 contains more than 1 0. So this is an assignment problem which has an alternate solution. Let us make arbitrary assignments. So the optimum assignment is A we have assigned with job number 4 is assigned to job 4, B is assigned to job number 3. Now in the third row there is a choice. Either you can use job number 2 or we can use job number 5. Let us use anyone, say job number 5 we are using here. So you can draw a vertical line for this when we make an assignment in a row. Draw a vertical line like this so that this 0 we cannot use for further assignment. Now this we will not use for assignment. Now row number 4 there are 2 0 and row number 5. Now there is a single zero in row number 5. First, we utilize this zero, single zero. So E is assigned job number 1. We use this for an assignment. E is assigned to job number 1. We cannot assign the same job to D. Only one choice left. We can assign this person to job number 2. So this is a one solution. So since there is a choice, we can write alternate solution. When we use different zeros, we get different solution. So let us write down the optimum assignment cost or minimum assignment cost for this problem. First, we have assigned A, clerk A to job number 4. So C14, the cost is C14. Let us see what is the cost in the given problem. The cost is C14. This is a cost. Look at the cost. It is smallest. So the assignment will give you smallest cost of assignment. Now second assignment is clerk B is assigned to job number 3. So C23, second row, third column. Second row, third column. This is the cost of assigning operation B to machine 3. Now let us find the cost of assigning operation C to which machine? Let us see in the solution. Operation C is assigned to machine 5. So what is the assignment cost? C is assigned to machine 5. The assignment cost is 3. Now operation D. D, we have assigned of this operation to machine number 2. So 4, 2, fourth row, second column. Fourth row, second column. This is the smallest assignment cost. And last, operation E is assigned to operation E is assigned to machine 1. So C51 is the cost. C51. So we will add this cost to 2, 3, 2, 6. 2, 2, 3, 2, 6. So the total is 15. So minimum assignment cost is 15. So this is how we solve the assignment problem with restrictions. In this assignment problem, there are two restrictions. These are the restrictions. Operation A cannot be performed on machine 3, whereas operation C cannot perform on machine 4. Or this job A cannot be performed on machine 3 and job C cannot be performed on machine 4. Or clerk A cannot be assigned the job 3, clerk C cannot be assigned a job 4. Like that. There are two restrictions. For this assignment, we take a very high cost, that is, we take this cost as infinity and apply usual method, Hungarian method, to solve this problem.